Hi, my name is Mohammed Tariq, and in this lecture, we will see the formation of binary search tree. We will create the binary search tree, and we will see how this can be created using the tool created by Jacob Melinzek. This is a very handy tool, and it helps us to understand how a binary search tree can be formed and how can we visualize the formation of binary search tree. So when we write the code, it will help us in writing the code. If you have this visualization in mind, you will write the code easily and with better understanding. So in this lecture, we will focus on only the creation of binary search tree. There are some other functions like delete function, find function, traversal functions, pre-order, post-order, in order, but we will not focus on those functions right now. We will be only focusing on the creation of binary search tree. So let's start creating this tree. I have some numbers with me, so I will start with the root node and then we will proceed. So the first number I'll insert is 100, right? And this is a button using which I can insert the 100, the root node, and this will be displayed in this section. So I've inserted the first node, and this is the root node. Now, now I'm hoping that you have the binary search tree rules in your mind. So let me review. The rule is on the left hand side, if we have a root node, the left child will be lesser than the root or this parent, and the right child will be greater than its parent, right? So this is the rule. Now the second number we have is 150. So according to the rule, where the 150 would go, so it should go on the right hand side because 150 is greater than 100. So the 150 is greater than 100, it goes to the right hand side. Now the next number we have, let's say we wanna insert 200. So where it would go? It's greater than 100. It's greater than 200, 150 also. So the 200 would be here on the right hand side of 150, right? So here is 2 is greater than 150, and this is the correct location of binary of the node 200. Now let's insert 50. So where the 50 would go? It would it should go on the left hand side because it's lesser than the root node. So 50, and this is the correct location. Now we have 120. Let's insert 120. So where should it go? It's greater than 100, but it's less than 150. So the correct location is the left child of 150. Now we have 52. So, okay, where it would go? It's less than 100. It's greater than 50. So it's the left hand child, sorry, the right hand child of node number 50. Now the next number we have 45. So I have some random numbers, and I'm just putting some random numbers to make you understand how the tree is forming. Now the next number we have is 46. So 46 is less than 50, is less than 45. So here it goes. Now we have 125. So 125 is greater than this, is less than this, is greater than this, and this is the correct location. Now we have 130. 130, where 130 would go? Greater than, less than 150, greater than 120, greater than 125, and this is the correct location. And now let's we have 110. 110 greater than 100. Sorry, yes. So here is the correct location. Greater than 100, greater than 100, less than 150, less than 120. So this is the correct location. And let's input a last number, which is 40. So it would, where would it go? Greater than, less than, less than, less than. So this is the correct location. So this is how the binary search tree can be formed. And I hope this formation will help you in understanding the code. When we'll write the code, keep this visualization in mind, keep this structure and the formation structure in mind, and then we can write the code. And when we will write the code, you can better understand the flow of the code. I hope this will be helpful for you, and I'll see you in next lecture. Thank you.